Hi, everyone. Thanks for being here today. Feel free to join if you'd like, just starting. Oh, okay, thank you. Awesome. Thank you, Dylan, for that introduction. So I'm actually the chair of the Forum on Physics and Society this year, so I'm especially glad to welcome you to a session sponsored by the Forum. So I'd like to get a sense of who's in our audience today. So if you are affiliated, either student, faculty, or staff of a flagship or an equivalent Research One style institution, could you raise your hand? Yes, okay, we've got a half. Okay, two. Okay, kind of. Okay, cool. What about like a regional research institution, like Cal State System or something like that? Yep, okay, cool. Okay, what about like a predominantly undergraduate serving institution or community college? Okay, so those also include, got you. Okay, awesome. And then what about industry or national labs or other folks who are participating in the research enterprise? Okay, we got one of those. Anyone not have their category called? Okay, great. That's really helpful. Thank you. Okay, so today I have a few points that I hope you will, questions that you'll be able to answer as you come out of this talk. Now I want to preface this. I have a lot of information on my slides because this talk and the slides are being recorded and will be made available on the APS YouTube channel. So this is partly for folks who will be watching this in the future and for you to reference them later if you so choose. So questions I hope that you'll be able to answer are, what are the ways that higher ed institutions are classified? And why does it matter which higher ed institutions participate in scientific research? What federal policy changes are underway which affect which institutions participate in research? And why does this all matter for non-emerging research institutions? And so this talk is actually based on two papers. Well, one's an opinion piece and one's a policy paper, but the links are there. The first was published in Issues in Science and Technology, and the second was published in Physics. Okay, so I'm going to be talking about policy, so I like to start. I don't know, you got to make sure we have a diverse audience here. So this is just a quick overview of the U.S. federal government. So we are a government of three co-equal branches. The legislative branch is composed of the U.S. Congress, and it makes laws. Then the executive branch, which is headed by the president, but also includes all of the federal agencies, like when we talk about the National Science Foundation, the Department of Energy, et cetera. Those are all under the executive branch, and they exist to carry out laws. And then the judicial branch interprets laws. So today I'm going to be talking about in the interplay between the legislative branch and the executive branch. Okay, so here the US government has tracks information, a whole host of information about every single higher education institution in the United States. So the data set from the US Department of Education that tracks the location of institutions, their student enrollment demographics, I mean a whole host of information is called IPEDS. And if you go to IPEDS, you can bring up this map, which is a map of all nonprofit higher education institutions in the United States. There are over 3,600 nonprofit higher ed institutions. Now, from an access and equity perspective, I'm sorry if those are, if anyone's blue-green colorblind. I don't choose the color scheme here. But anyways though, so you can see the blue are publics and the greens are private. There also are over 2,000 for-profit higher education institutions in the United States. But we're only going to be talking about nonprofits. So there's a lot of institutions. You can see they're spread all across our country. Of course, you could see a concentration east of the Mississippi, but that's where all these institutions are. Okay, now these institutions, they're diverse. They have wide-ranging geography, right? They're in different states. They're in different places within their states. They're in different types of communities, urban, rural, peri-urban. I think there's 8 different points on the urban to rural scale that the Department of Education tracks. They have wildly different levels of resources, whether bringing it in external funding or internal funding or fundraised money like endowments, et cetera. They also have, in terms of resources, varying institutional like political capital, reputational capital, right? That's all a resource. Alumni bases. They also have varying institution characteristics. What size of institution, how many students they're enrolling, what types of programs do they offer? And then of course their student bodies have different characteristics. What is the average age of their students for undergrad or graduate? How many first-time college, first-generation college students, Pell Grant recipients, which are low-income students, race and ethnicity demographics, immigration status, tons of different characteristics of their students. So when you classify higher education institutions, you can do this in a number of different ways. I'm sure the physicists in this audience can imagine probably 50 different schemes or more for this incredibly complex and rich data set. So here are some common ways that higher education institutions are classified. The most common one is the Carnegie classification system. It organizes institutions into Research 1, Research 2, predominantly undergrad, masters. There's lots of different, it's a very rich classification system. But you primarily hear about it referring to Research 1 institutions. Those are this kind of quote unquote upper echelon, top tier of research institutions. And those, this is kind of my little shortcut for how they're classified, by resources, by institution type, and by their students. You also can look at, there's another one that the federal government uses called EP score or DEP score. And that is basically looking at, by state, how much research funding from specific agencies go to individual states. And if it's below a certain threshold, they qualify for this special classification and program. There's minority serving institutions, which look again at resources, institution type, and students, et cetera. So there's lots of different ways you can think about classifying higher ed institutions. So when we're thinking about I guess I should say, let me go back. So on classification systems, why this matters is because the US Congress loves to control where resources go, right? You saw that map where there are higher education institutions all across the United States. Every single one of those institutions has 2 senators and 1 House member. And so their job, those elected officials, is to look out for the interests of their constituents. So the Congress can be involved in directing resources to institutions within particular classifications. And so that's how you kind of get this emerging research institution thing coming. Okay, so I ask you to consider, when you get a federal research grant, it's a balance between the innovation and discovery activity, the research outputs that the grant is designed to support, like new discoveries, learning more about the universe, and education and training. Because the people who are actually doing that research are largely students and from undergrad through postdoc. And so there is a workforce development component to your federal research grants. And so when you're thinking about a single federal dollar is often, from a research program, is actually asked to do these dual purposes. Now sometimes these purposes can be in competition with each other. And sometimes they're supportive. But I think that a lot of times folks, especially at our R1 friends, may think they focus on, and Congress talks a lot about, the innovation discovery component of a grant, but there's also this very important and real education and training component. So I'm going to tell you a super quick story about Northern Illinois University to illustrate the build to this emerging research institution definition. So Northern Illinois University is a university that I represented. I worked for in Washington, D.C. for over 8 years. I ran their D.C. office. And so you can see the institutional demographics. It's a Carnegie classified Research 2 institution, 16,000 students, 79% identify with various types of underserved populations, a large population of undergrad transfer students. And the research portfolio is $9.8 million in federal research, including $3 million from the NSF and $3 million from DOE. So they're doing, actually producing research. Okay, so there's a little timeline you're going to see in the upper right corner. So I would bring faculty members to meet with federal program officers back 2018, 2019, and I noticed this trend with the helpful advice that my faculty were being told, which were things like, that's a really great research idea, but the truth is, with your institution as the lead, it's just not gonna make it through the review committee. So you need to just find a friend at go to Northwestern, go to University of Illinois at Urbana, find a friend who'll be the PI, and then just have them sub the work to you just to get it through the review committee. And the program officer would say this as a helpful piece of advice on how to get your idea funded. We also heard things in reviews such as, that's a really great research idea. We think that you could execute it. Well, we think it should be done. We think you have the resources, the equipment, whatever, but your institution is just too small to take on a project of this importance or this magnitude. And we also heard things where they would say, well, you say in your application that you have this piece of equipment that's essential to this project, but we're not really sure you know how to operate it. I mean, you just hear these kinds of things, and so we're just like, what is going on? So meanwhile, around this time, there's a new marquee legislation that's proposed called the STEM Diversity Bill, the STEM Opportunities Act of 2019. You can read what it does, but basically it just requires more data capture from the US, from the federal research agencies. It doesn't have any funding associated with it. It's just like trying to identify the problem and capture it a bit more. Then also, May 2020, flash forward a year, the National Science Board comes out with this report called Vision 2030. And this, if you take nothing else away from this talk, please remember this plot. So in this figure, they titled it The Missing Millions. And what it does is they projected forward to the year 2030 how many individuals would need to be in the STEM workforce of the United States, and then they looked at current rates of women, Hispanic or Latino, and Black or African American individuals in their current proportions, and said if we project that forward, how many women will be in the STEM workforce versus how many would need to be there to have their representation be what it is in the US population. Okay, so that's what all the filled little people here are where we will be without doing anything else and just continuing current trends into 2030. Where we need to be, where if women, Hispanic or Latino, and Black or African American individuals are represented at their population level, but in STEM, those are all of these little empty people on the plot here. And so this has really become a driving part of the conversation in federal policymaking circles on access and opportunity in STEM. It's called the Missing Millions. So we're aware that we're now missing millions and millions of people, of women and people of color in STEM fields, and this is a problem for the nation. So then we have a big piece of legislation introduced. This was May 2020, called the Endless Frontier Act. It eventually became the CHIPS and Science Act that Dylan mentioned, but Senator Chuck Schumer introduced this back in 2020. It authorized $100 billion for the National Science Foundation over 5 years. Like, wow, that'd be amazing. Except there were no provisions in it to share the wealth or do much to address the missing millions. It just was take your existing programs and like pump more money into them. And so it would be replicating the current inequities we have in our distribution of federal research funding. So then I'm sitting here thinking, okay, America has a major shortfall of students of color in STEM. Northern Illinois University is a research institution that educates mostly students of color, yet neither the marquee NSF bill nor the STEM diversity bill would really do much for Northern Illinois University. So what's going on here? But then you could be thinking off to the side, but hey, aren't there already federal programs for campuses that educate a lot of students of color? And there are. There's called the Federal Minority Serving Institutions Program. And this is one of the classifications that I mentioned earlier in the talk. Here is a list of different federal programs that fall under the heading of minority serving institutions. You may have heard of these, MSIs. I think some of you are actually from MSIs here in the audience. And so they can be historical or like legislatively deemed, such as historically Black colleges and universities or tribal colleges and universities. They can also be institutions where you kind of get into them through your student enrollment and other characteristics of your institution. I'm going to talk a little bit more about this in a second. If you want to know more, there's actually a center for MSIs at Rutgers, which has a lot of data where they study MSIs. So you can take a look at that if you want. So, oh, I just mentioned this. Okay, so for option one, you can be a legally designated, like historically black college or university, or you can become eligible. Now, here's the key. To be a federally designated minority serving institution, most people focus on the minority enrollment piece. There actually are two other components that relate to your institution. Number one, you have to have low education and general expenditures compared to the type of institution that you are. So basically, the US government says, you have to be a good value for students. You have to cost less than your peer institution type. Yeah, I know, I see some faces like, what? Yes, this is a requirement. The second other requirement people don't talk about is you have to have a high enrollment of financially needy students compared to your peers. And then, of course, there is, number three, the minority enrollment percentage requirement. Take a look here. Depending upon the type of minority, the race ethnicity category, you have minimum enrollment percentages. So if you are a campus that's not a historically black college or university, but you enroll a high percentage of African American or black students, you have to hit 40% of your students as African American or black to qualify as a minority serving institution, which would be the predominantly black institution designation. Whereas you only have to enroll 10% of your student body as Asian to qualify as the Asian American, Native American, or Pacific Islander serving institution. So there's a lot of politics that goes into back in the day when these percentages were set, which we could talk about offline if you'd like. But this is the MSI programs. So the thing is, there are hundreds of schools that are actually educating a majority of students of color, but are ineligible for the minority serving institution designation. And so there are, if you look at the data, there's 199 students that don't meet the minimum race ethnicity enrollment thresholds, but are still educating a majority, over 50% students of color. There are also 159 institutions that don't meet the low cost or needy student criteria, but again are educating over 50% students of color. This doesn't even include what institutions are educating 10% Asian students but don't meet the financially needy students or the cost of education criteria, like Harvard, actually. Harvard enrolls 20% Asian students, but they don't qualify as a federal MSI because of those other two criteria I mentioned. And so just here are some examples. If you look at Northern Illinois University, I just updated this data this morning. Northern Illinois University is 55% students of color in these categories that are tracked by the MSI categories, but since they're only 24% Hispanic, they are treated on paper as a white institution. So this was a challenge, and I give another example, right? It's not just NIU. I give UNC Greensboro as another example. So, okay, let me keep going. Okay, so in talking about these questions with my friends at the American Physical Society DC office, we asked this question, well, what happens if you just look at the enrollment data by institution and compare that to the federal research funding data by institution? Like, what are you gonna see? Because my hypothesis is there's a lot of schools like NIU that are really doing the work that the nation says they want done, right? Trying to solve the missing millions issue, but are not getting the dollars on their campus to actually provide high quality research experiences for students on campus. So what's going on? So, oh, this is just one of those slides. So here's the data if you wanna look up the data yourself. So when you look in this report from APS, you'll see they looked at the top 139 institutions. They received 90% of federal research funding. You see that on plot number 1. However, the percent of students they're educating is only 43% of the students who have research active, who are listed as research active by the National Science Foundation. And so these are all campuses. I should back that up. The data set here is about 650 institutions that report to the NSF, the National Science Foundation, research survey annually. So the NSF asks any campus that received over $150,000 in federal research funding, not just from NSF, from any source, any federal source, to say, hey, tell us about that funding you got. Where'd you get it from? How much was it, et cetera. It's a very well characterized data set, federal data set. So there's about 650 schools that participate. And so the top 139 get 90% of the money. So if you just look at this question of what about the students who are attending one of these research active schools? Because sometimes the arguments I hear are, well, if these institutions were any good at getting research money, they would just be getting the money competitively. Or you hear, oh, a lot of these schools don't want to do research. So we're just saying, hey, let's look at the campuses that are getting federal research dollars today, right? There's no question, are they capable or are they interested, because they're getting the money already. And if you look at that, and a stunning turn, I think, the percent of underrepresented minority students who are attending one of these schools that receives 90% of the money is only 34% of the students who attend a research active institution. And it's even smaller, it's only 32% for Pell recipients. So basically what this is telling us is 2/3 of our students of color who attend a research active institution are attending a campus that that collectively receives 10% of federal research funding annually. And the same thing of our low-income students. So in this article, they proposed a definition of emerging research institutions. Oh, sorry, these shouldn't have gone away. They propose a definition which is just looking at the size of your federal research portfolio, not trying to mess with, what types of funding are you getting and, et cetera. It's like, let's just make this easy. Just how much money did you get? If it's above a certain threshold, you don't qualify. If it's below, you qualify. And you have to have students, because the whole motivation for this is students. So you won't be an independent research institute that receives, not much funding, you don't qualify. And so all historically black colleges and universities and many minority-serving institutions would meet this definition. And so this is then what happened is, by the magic of lobbying, we got this definition into the CHIPS and Science Act with some modification. And so the modification was you could have undergraduate or graduate program. And so this year, looking at the data, there are 167 non-emerging research institutions. So when we made the data the plots a few years ago, there were 139. Now there's 167. But there are thousands of emerging research institutions still. And this year, only 466 ERIs reported research activity to the National Science Foundation. And some agencies, though, don't include community colleges, so how do you put an exact number on it? It's a new definition, so it's still being worked out. But that's the status right now. So let me show you this data here real quick. So I went through the latest NSF data, and you can plot, looking at the 167 research institutions that are not emerging research institutions. So their research portfolio, federal research portfolio, is $50 million or more. They received 13 times more federal research money than all of the emerging research institutions combined. It's actually 93% of all federal research funding this most recent year. And then you can look at, Department of Defense, it's 12 times, DOE 13 times, et cetera. And so that's our current state of play. The NSF is doing pretty well because they have such tremendous prioritization of being more inclusive in their research programs. Okay. So here's a quick little case study on the state of Michigan. We don't have much time, so I'm just going to super click through it. The blue one is University of Michigan, Ann Arbor. The orange one, and we're going around clockwise, so the orange one is Michigan State, the silver one is Wayne State, and then the kind of yellowy orange is Michigan Tech, and then it's all the rest. So these are all of the institutions that reported for the NSF HERD survey from the state of Michigan. So it's a lot of schools. So if you look at just the University of Michigan, Ann Arbor, which is orange in this plot, compared to all of the emerging research institutions in Michigan, this is the funding. And I picked the only reason I picked Michigan is because I gave a talk there last year, so I already have these slides made. But you could pick any of your large R1s. You could pick Berkeley, you could pick, pick any of your Harvard, Princeton, whatever, right? You could pick any of your big R1. And so this is how the University of Michigan compared to all of the ERIs. Now let's look at the enrollment data, however. In this plot, University of Michigan is silver. The non-ERIs and all of the non-ERIs are orange, and then the ERIs are blue. And so you can see the University of Michigan's Pell enrollment is minuscule compared to the ERIs in Michigan. So it's an example of just the larger national trends. playing out in this single state. And you can see that with race and ethnicity enrollment, et cetera. So, okay. So this is a problem because you have students who are place-bound. There are a lot of students that, for various reasons, cannot pick up and move to some other location that's far away from their families and their communities. At Northern Illinois University, there was a survey that was done while I was there that found that 20% of our incoming freshman class one year self-identified as the primary caregiver for at least one other person. So if you live in a multi-generational household where you have caregiving responsibilities for a grandparent or a younger sibling or a cousin or somebody, even if you are the most brilliant person ever, you cannot pick up and move to University of Michigan at Ann Arbor because you have reasons that you're tied to place. You also could be tied to place because you just don't want to move. You like where you live, you like your place that you are. Also, number two, the National Academies has a number of reports that have very well documented that participating in research is a high impact practice for undergraduate students to develop interest in and persistence to graduation in STEM. And they develop self-efficacy and identity as researchers. It's a very well understood mechanism for getting students to and through STEM degrees. And then finally, as you've seen, emerging research institutions, they are educating a very diverse, not just race, ethnicity, but socioeconomic, geographic, et cetera, group of students. So, okay, I'm gonna flip through real quick. So we talked about the MSI programs. This past year, though, only $1.2 billion was spent on MSI programs. Let me give you some baselining. The National Institutes of Health, that annual budget is $50 billion. The National Science Foundation's annual budget is about $8.5 billion. So it's a lot of money, but in the grand scheme of federal research money, the federal government spends over $50 billion on research just at universities every year. And so there is the EPSCoR program, I mentioned that. In blue are all of the states that qualify as EPSCoR states. And so you can see they're spread around. Okay. Yeah, so here you can see the facts. EPSCoR populations, the EPSCoR states are 22% of the US workforce and 16% of science and engineering doctorates, but they receive only 13% of NSF's funding. And so there's this effort to redistribute that. The CHIPS and Science Act has over 15 mentions of emerging research institutions, and it also creates a pilot program at the NSF to foster meaningful partnerships between emerging research institutions and other lead institutions. NSF is still developing this pilot, but it's in there, it's in law. So, so there's that. Okay, I'll skip this. Okay, also in 2020, in this summer, I gotta go quick. Okay, this summer, President Biden releases the annual budget instructions to the agencies. And one of the priorities was reducing barriers and inequities in research, and emerging research institutions and investments in historically underrepresented communities was one of the priority areas listed. So here, this is for your reference when you get the slides later. There are now a host of programs at the federal government that are designed to support emerging research institutions, some of which also apply to community colleges. In fact, if you look at the Department of Energy's science budget request, emerging research institutions appear 51 times in the science budget request for the Department of Energy this year. I'll skip this. Okay, so what this means for you, okay, skip that. Here we go. If you are from a non-emerging research institution, there are now going to be these requirements for meaningful partnerships with less resourced institutions in some federal grants. So start your friend making now, because this is coming. You're also going to see more solicitations that are only eligible and open to emerging research institutions and subsets of such, like minority-serving institutions and others. So what everyone can do to prepare is start building collaborations that span institution types, that span geographies. Really start working on that, because that's where the focus is from the federal government now. So this rebalancing is going to be slow, right? But it's taking shape. And I don't think, even despite how we're in an election year, et cetera, there is political and social momentum for this movement. And so that is, there's especially a focus on regionalism and place-based innovation right now. You see that with tremendous multi-billion-dollar investments from the Economic Development Administration and the NSF in regional and place-based innovation. But this distribution, it's only going to change so fast, right? You're not going to move this ship overnight. But there's a real cost to slow progress, and the cost is human. It's also economic, because these are folks that should be working in our innovation economy and contributing their unique and vital perspectives. So, okay, well, that's a feedback thing. So anyways, if you have any questions, or if you want to continue talking, I'll be at the conference all week, and you can always just Google me. I think I'm the only Anna Quider out there. So you can find me, or you can shoot me an email, or find me on LinkedIn as well. Okay, thank you. Sorry I went over, Dylan.
We still have time for questions, if anyone wants to ask questions.
I think that 40% Black or African American, like where did that number came from? Is there just someone just made a number and then that stuck?
Yeah, so the technical answer is we can go back and look, so to make all of these changes, all of these designations for the Minority Serving Institutions program, they are in the Higher Education Act. And so the Higher Education Act originated in 1965, and it's been edited multiple times since then. The last time it was edited was 2008, but those specific edits that have happened to create these different minority serving institution programs, I think they started in like the 90s and have kind of they were tweaked throughout. So I can speculate, but I am not certain of the political origin of that number. But I would be happy to speculate to you, not when I'm recorded.
Okay. Are there any additional questions? Please.
Is there, so you're effectively lobbying on behalf of emerging research institutions. Is there a group, like I'm part of one, but is there a group of people that's designed around this designation yet for like the actual institutions that are members of that group?
Yes, so I'm creating this. Okay. I swear I did not tee that up. But yes, because when I represented Northern Illinois University, I was one of only two non-research institutions that ran a full-time Washington, D.C. office. One of only two in America. How many of those 135 or 166 non-emerging research institutions do you think have full-time Washington, D.C. offices? Like most, if not all of them. And so I think to your point, Wing, though, I just think and I was the APS Congressional Fellow way back in 2011, so one of my passions is helping folks understand how the politics of it really impacts the science, and who is allowed to do science, and where the money goes, and how these designations are written. That's all Congress and the agencies. And so I want to make sure that you all are understanding, and it's your democracy. So you fully, there are people that make these decisions that are answerable to the American voters. So that's where your participation in advocacy and coalitions and that kind of stuff, it's really important. If you don't like how things are, then we have mechanisms in our democracy to try and affect change. And sometimes they actually work.
In terms of the partnerships with HBCUs and tribal colleges and universities,
yes.
How do you foresee that happening? I know there's some, but like what's the path? Is there a designated path for some of the universities?
Yeah, so I think one of the challenges that we were trying to address in creating this language that says meaningful partnerships is to avoid this kind of predatory model where a large institution or consortium develops an idea and it's fully baked, and then they realize, oh, this would look a lot better if we had an HBCU as a partner. So then you go find an HBCU to co-sign it, and you tell your HBCU, like, look, it's baked. You sign on the line, we'll give you some money, but we didn't really need your intellectual contribution here. So that's where this meaningful partnership language tried to avoid that. In terms of the mechanisms, I think that there are some organizations that are trying, that represent HBCUs, where you can try and plug in with them. But it's challenging, because we all know as physicists, collaborations are based on trust, they're based on relationships, they're based on individual knowledge of capabilities and who's good at what and wants to do what, and et cetera. So it's kind of like dating. And I think that we just need to foster more individual PI to PI relationships. I think that we can start seeding that earlier and earlier with student exchanges, but that also is challenging for place-bound students, especially Pell students who have to keep their job, in the summer. They can't just go and do an REU somewhere for the summer. I mean, it's a complex problem, but I do think, I'll say one more thing, the agencies are really aware of this, and they are trying to use their clout and mechanisms to try and foster relationship building and matchmaking. So I think that you'll see more and more efforts toward this, but at the end of the day, nothing stops folks from picking up the phone. You saw a paper you liked, call the person, try to talk to them about it, try to build that relationship.
Okay, thank you very much. I think we have to move on to our next speaker. So our next speaker is Aurora Pribram-Jones from University of California, Merced.
How's that? Hi. All right. Oh yeah, it's gonna panic about Adobe, but up here we can. Yeah. And then it's this one here. Oh. Yeah, I had it working before. I can. It's okay. It'll work. I can do a dance. I can do all kinds of things without slides if necessary. Don't worry.
Everyone can ponder the little blue ball while we...
Okay. Oh, I see. Yeah. All right.
And that'll be remote if you want.
Okay. I see. Okay. Oh, and I get a thing. Okay, I'll use this thing. Hi, everyone. Thank you so much for having me. Nice to see faces I recognize also. So I'm excited to be here. This is my first April meeting. I'm usually a March meeting person. And I'm really excited to talk about some of the many ways that we at UC Merced as an emerging research institution have been able to work through DOE initiatives to build our research capacity, but also to provide new and meaningful experiences, particularly research experiences for our students at all levels. So first what I'll do, oh, it's not advancing. That's fine. I don't need it to. Yeah. So if you're not familiar with the University of California, Merced, that's not that surprising. We're only about 20 years old, right? We were founded in 2005. We're the most recent campus of the University of California. We have we're wanting to be at 9,000 undergraduates, probably want to be at 10 by now, right? But COVID took us down a little bit here. But 8,300 undergrads, and we are a Hispanic serving institution. We're also an ANAPESI, so an Asian American, Native American, Pacific Islander serving institution. That's special to me because I'm part of that group as well. And we are about 65% first generation college students at this point. And we really, we look like California, right? So it's not the typical experience of walking into a pale and male institution that you get when you go to a lot of UCs, even the ones that are designated as Hispanic serving institutions because they have a lower percentage. That's not really what California looks like. And those of us that work at emerging research institutions where that's it's not just a numerical designation, but is actually part of the character of our institution, you feel a difference, right? We also we're not a primarily undergraduate institution. We have master's and PhD students, and we have about 775 graduate students now, and that we're trying to grow that part of our program quite a bit. And right now we're at about 445 faculty, but that includes both ladder rank, so both sort of tenure track traditional UC professors as well as lecturers with potential for security of employment, which is like the teaching professor track. Of those ladder rank faculty, we have about 300. So it's become quite a big place, and I've only been there since 2018, and the size of the campus is massive compared to when I first got there, both physically and personnel-wise. We are located in the middle of a lot of beautiful things, but we are in a part of California that is historically underserved. We're medically underserved, economically underserved. We have a strong tradition in the Central Valley of activism and community building, but in general, when people think about California, they think about coastal communities. They do not think about those of us that are in the regions of California. They're in the middle here, particularly as you move further south. So this is called sort of the gateway to the Central Valley in Merced, and we are cognizant of the fact that we are in the Central Valley, but we are not necessarily always considered of the Central Valley because we are a little bit north for a lot of Central Californians. So we really try to think carefully about serving that entire community. I have a colleague who jokes, wow, yeah, you're like 2 hours from lots of things, which means you're close to nothing, right? But that's not true. You can get to Yosemite really quickly, and there's a lot of art and theater in Merced, and so the students that come are often coming from California. We do have an international community, but the vast majority of our students are from Southern, Northern, and Central California, and it's still about a third in that mix. So that's sort of the institution by the numbers. But yeah, as I said, I think we're entering our 20th. We're going to be entering our 20th academic year. Stuff that we're known for at this point, we exceed national graduation expectations. We have a lot of first-generation students and a lot of low-income students, as I said. And so the graduation expectations for people in our demographic groups are usually lower than what you see at our campus. We are known for being the fastest ever rise to this Carnegie R2 status, right? And if you talk particularly to administrators and certain parts of our faculty, the push for R1 status, right, becoming one of these premier research institutions, like many of the other UCs, is a big deal for us. Those of us that appreciate that may not be always done in an intentional way think a lot about how to grow with intention. Because being an R2 institution and pushing for that, being very research active, but not having a massive graduate and postdoc population means that we have a huge number of undergraduates in our research programs. So we have the highest participation in undergraduate research in all of the universities of California by percentage. We're very successful with research, right? We have more than 10% of our faculty are getting things like NSF Career Awards. And we're not, we are a 1-1 school, right? So research faculty, people on the tenure track only have to teach one class a semester, which gives us a lot of advantages compared to some of our other collaborators who are shouldering massive teaching loads. We also are pretty known for interdisciplinary research. That happens when you're sort of all in one building because you're small, right? Everybody's working together. When I started, right, chemistry, physics, and math were all on the same floor. It's a little bit different now because in that time we've had twice the buildings built on campus that were there when I got there. And so now keeping those interdisciplinary ties requires effort and things like that, but you see that we have a lot of ag tech. We were designated an agricultural institution for the UC recently. We are, big focus on climate science and sustainability. We work a lot in social justice and public policy, and we're known for computational physics and chemistry, which is what I do, so I don't know if everybody would say that, but we have a pretty large group for the size of the departments that we have in chemistry and physics. We have, depending on how you count, 7 or 8 different computational chemists and physicists really thinking about computational studies for those chemical physics problems. So, what I wanted to talk talk about today is just a piece of this larger effort that we have. And in particular, thinking about, can we think about supporting these minoritized students, right? Because at our campus, the students that are thought of as minority students are not actually minorities on our campus, right? They are minoritized out in the wider world, but maybe not on our campus. But they are all certainly underserved. Simply by being in the Central Valley, they become underserved, but a lot of them come from very low-income communities or, groups that have experienced historical and current bars to participation. So if we think about supporting these students, can we think about how we can also build research capacity for these emerging research institutions? And some of that is about this hard work that you're doing, right? But for those of us doing the work in the institutions themselves, we also have to build those things so that we get our security of employment, and that so that we can build more opportunities for the students, and that they come out of these programs being at the national, international level at which they need to be competitive. And so for the example that I'm going to use today is high energy density science, which is one of my research areas. And I'm going to be talking a lot about the various Department of Energy programs that we've been a part of. And in particular, at the end, I'll talk about how that has driven stuff in my research group, which is sort of the technical. I'll nerd out at the end just a little bit. Okay, so just to sort of get us started with what is high energy density science. I know this is April meeting, so y'all know a lot more about this than some of the folks at March meeting, right? But when we talk about high energy density science, the other things that we are talking about, from my perspective, are we're thinking about quantum mechanics. I'm an electronic structure theorist, so I think a lot about quantum mechanics and condensed matter. And most of the time we hang out in this chilly quantum world where we just pretend, listen, we're at zero temperature, who cares? And the reason why is because electronic states are just not thermally accessible. With the thermal energy in the room, for most quantum mechanical problems, you don't need to worry about that. But as soon as you are thinking about states that are accessible to you, whether that's by increasing the energy that's around you by increasing the temperature, while keeping the density high, like you might have in the centers of giant planets like Jupiter there, or in shock compression experiments, or thinking about the ignition of fusion, or if you're thinking about transitions like in topological phase transitions where the energy differences are very small. Now you have to start really contending with statistics and thermal effects. And so for us, thinking about how to deal with these thermal effects in electronic structure led to my research program having a lot to do with things like that they do at Lawrence Livermore and other flagship facilities from the Department of Energy, where they are trying to do these things like, we're building a star on Earth, right? Trying to ignite fusion, or where you're just trying to look at what happens to materials under extreme conditions. So this has naturally led to me having a lot of engagement with the Department of Energy since my graduate school career. That set me up very well, right? Like I was familiar with a lot of DOE language. I was familiar with a lot of DOE people. And it meant that I got to do a postdoc at Lawrence Livermore National Laboratory and could go and visit some of these flagship facilities. But that was really only possible because I was at an R1 institution that was on the rise, right? So people were willing to take a chance on me doing this in a research group, which was a little bit of a shift in that research group's priorities. If you're coming from an emerging research institution where you're already contending with things like, well, can you really handle that? Those opportunities wouldn't necessarily be available to you unless you have advocates that are already doing that, right? That allyship and thinking about this coalition building, it was very key to me, like very early on. I was a community college student also, so I know what it's like to not have research at your institution. So I could very clearly see how that sort of transfer of privilege can be really, really useful. When we're talking about high energy density science, some people, mostly me now, I think, call it the malfunction junction because it sounds like the way I talk. The reason why is because when you think about the ways that we talk about theoretical treatment of different states of matter, warm dense matter and this high energy density science region, which is sort of denoted by this dotted area here, loosely defined, or sort of with this green line, these are complicated regions of space. They're high temperature and high pressure at the same time. They're high energy. They have a lot of strong correlations. They have partial ionization, pressure effects, a lot of things going on. And so the the simplifications that we make, either thinking about chilly quantum world or up in traditional plasma methods, we can't use those same things as we go toward this middle section here. And that's this malfunction that they're talking about. Trying to stretch methods that aren't really designed for that area into those places doesn't work anymore because you don't have those simplifying assumptions available to you anymore. So you can imagine that this means that, you know, there's a lot of state-of-the-art work here, and there are people that have worked in this field for decades, but there's a lot of interest in building a highly expert, diverse technical workforce for the future, right? Like this is, you know, the DOE language. Woo, yeah, we need people that know how to do high energy density science. And part of that means having people who are familiar with a huge range. This is just the theory part, right? Like if you talk to people who actually know how to do this and are thinking about experiment, there's a whole other slew of things that students need to be familiar with. So if we're thinking about the methods that are available now, right, we have things coming from plasma physics, condensed matter physics, quantum chemistry, machine learning, all kinds of things. And that's just the stuff that we do well so far, right? So to find students who are well-versed in all those things means you need to have a training center, right? Whether that's within an institution or across a field that's also well-versed in this. It's very rare to find someone that walks out into the professional world with all of these skills. And so then when we think about what we need to do next, where we fall short is thinking about things like limiting behavior, local field corrections, non-equilibrium, and dynamics. All of these things that just make everything that we're interested in more and more complicated. And particularly thinking about computation and predictability, how do we know when things are going to be going well for us ahead of time? Like, can we predict when these things are going to shut down and cause us problems? How are they going to break down? And so for us, thinking about building that sort of capacity means that we automatically need a diverse team, right? Not only at the student level, which is what we've been focusing on a lot today and thinking about characterizing institutions, but also at the professional level. And the team level, right? If you're thinking about building national laboratory collaborations with academic institutions, you need that diversity of experience. So I was really lucky working with Eddie since 2018 and other folks. Right when I started my faculty position, there was a call through the Minority Serving Institution Partnership Program through the DOE's National Nuclear Security Administration, where this is a longstanding program, and Lawrence Livermore and Florida A&M and Morehouse College were putting together a proposal, and I was finishing my postdoc at Lawrence Livermore and starting at UC Merced, and I was very grateful that I was asked to be a part of this team, because they said, oh, you're going to UC Merced. Hey, is UC Merced a minority serving institution? I said, yes, it is. I would love to talk to you about that. I was really excited to get to do this, because this is, I would say that CFEDS, the Consortium for High Energy Density Science, has driven the research capacity for high energy density science at UC Merced almost entirely on its own. Because it's a really active, useful, and I would say organic, not in the chemistry sense, but like natural. Like we actually enjoy working together, and we do all have different skills that we can bring. And that has meant that we were able to build on that, pull out different pieces from that team in areas that make sense, not only to leverage other DOE programs, but to influence campus efforts like our Bridge to Research program, which is something that my collaborator David Stribba and I do just on campus with our own money or with CFED's money to get early research experiences going for, like before you would have somebody qualified for an REU, right? Like after freshman year. If you're trying to compete at national levels for internships at the Department of Energy facilities or at other big institutions, which is what a lot of our students need to compete as they go on. They're competing with people who started working in family labs in high school, right? Oh yeah, I called my aunt and she actually has an opening at her lab, right? That's not something that most of our students have access to. So we want to get them, by the time they're applying for those REUs, having some research experience that they can talk about, write about, and get letters for early on. So I have had some brilliant students that we've been able to place in research experiences on campus and at Lawrence Livermore as early as after their freshman year, which is a pretty astounding thing, but it took money to do that because our students, they work, right? And they're locationally constrained. Lawrence Livermore is about an hour and a half from UC Merced. So they can still be in touch with their families if they need to. Some of them have even commuted. Some of them have, I'll show some cool stuff about how we've had some online participation through COVID, and then after that as well. Beyond that, we're able to leverage not only like this excellent collaboration and seeing these teams, results from the CFED's work, and these other DOE programs, leading to other extended opportunities for my research program and David Striba's research program through the University of California Office of the President, and also through the Research Corporation for Scientific Advancement, right? So these are not even DOE programs, but they're able to build the research capacity of an emerging research institution because we had this great success working with this really powerful team. I'm very, being able to do research saved my life as a person who was, I had a lot of trouble feeling like I belonged once I transferred. And I was coming in late, right? And being able to work in research really allowed me to be present. And, retention and completion of these degrees is one thing, but if you don't even feel like you're allowed to walk in the door, that's a huge problem. So for me, making sure that there's some way for our students to actually feel like they have expertise or experience as soon as possible, it gives them bolstering to their scientific identity formation, right? I want them to feel, and not just feel, but know, be able to observe when the voices get loud, they can observe. I do have research experience, I must belong here. Okay, so now a little bit about CFEDs. As I said, it started in 2018. We've already had a renewal because we were very successful with this program. It's a collaboration. It's led by Charles Weatherford at Florida A&M. It's got Eddie Red from Morehouse College. We've got a ton of people on this, right? So we've got us at UC Merced, and then the two of us at UC Merced, David Striba and myself, and then a bunch of collaborators at Lawrence Livermore National Laboratory like Tony Bayless, Frank Graziani, we have Felicia Albert involved some of the time, and we've got folks like Ronnie Shepard working on experiment. So we have a mixed group. It's not just theorists and it's not just experimentalists, even though there is a big focus on computational study of matter under extreme conditions on the research side at the institutions. The internships that our students go to are all over the board. And that's really what makes this powerful. The focus on student research experiences is viewed as integral to building the research capacity, right? You'll tell me if I say something out of pocket, but I think this is true, right? We're all really focused on them finding something that they want to do. It's not just about supporting, oh, well, is that going to be connected to your senior thesis, or is that going to be connected to something that I can talk about later in my other grants? It has done that anyway for a lot of us, but to really have that time for students has been really valuable. And the other thing that's part of this, because MISIP has a lot of requirements, but I think that has been good for us, right? Like we talk about curricular development, and yes, time is limited, so we don't always do all of the things that we plan, but thinking about how can we use resources that Lawrence Livermore has with staff there to teach our communities about high energy density science? How can we build in pieces of that to things like general chemistry lectures or condensed matter physics classes at UC Merced? And how can we plan to figure out how to actually create modules that all of us can use within that consortium for building new coursework and leveraging things that are at R1 universities through other collaborations? So this is sort of just the idea that you really have this diverse community from these different institutions. And we're all, I think we all would fit under the emerging research institution umbrella, other than Livermore. But we're all very different in character, right? Like Morehouse has this brilliant mission that is all about undergrads, right? And for us, we are in this weird place where we're connected to this massive university system with the UC. Like we have lobbyists. They're not really talking about us though, right? They're talking about UC Berkeley. They're talking about UCLA. But we have those connections that we can try to leverage. Like, hey, can we have 10% of that? But then we have Florida A&M, which is huge, like just huge compared to a lot of us, and the history there, and the history with Morehouse and our, sort of juvenile institution at UC Merced. So being able to build on all of that and have Livermore say, hey, let's all get together at Livermore. Hey, we have faculty, we don't have faculty here, but we have visiting scientists that can do lectures. And we have mentors who really want to work with students because they don't get to do it otherwise, right? So they really have been good at serving as a supporting structure for this because they are as deeply engaged with our students as we are. Like they know our students. I can call out one of my students by first name on these calls, and people know who I'm talking about because those students have presented at our meetings every year since this thing started. So we've had really good outcomes in general, just at UC Merced, right? I think so David and I were talking about this yesterday. I think we've supported 17 undergraduates, both long-term research positions on site, and some short-term positions like summer internships. We've supported 5 graduate students through the majority of their PhDs, and we supported 4 postdocs. One of them was a Marie Curie fellow after this. So, it's a very powerful means of financial support for us as well. We have way more content on high energy density science, and just at UC Merced. And our students at all, both undergraduates and graduate students have a much better understanding of non-academic careers now, right? We have interaction, we have Livermore scientists coming and talking to them. They see their peers going there over the summers. It's not, like they can build their own imagination about what their future paths might look like because they hear something about it, or they're like, oh, what even is that kind of institution? Oh, there's a seminar about that. And then our alumni, undergrads are doing PhD programs at Stanford, UCSD, Delaware, right? They're prepared not only in a way that allows them to be at these major research institutions after their time at UC Merced through this program, but they also go there with the skills that you get coming from an emerging research institution. You're not waiting for an admin to do something for you, right? Because you didn't have one of those in your department, right? You're figuring out how to make it work. You're good at being flexible. You often have work experience, right? So we are able to highlight their skills, which is really what those research experiences let you do. And as far as building our research capacity, nobody, I know, like GPA and number of publications, those are just scalars, and we're complicated because we all like physics, right? We like vectors and matrices and tensors, right? But a scalar measurement of how successful this has been at building our research capacity is that just at UC Merced and Morehouse and Florida A&M, we have 13 publications and counting. I know there are at least 2 more under review from UC Merced right now, and most of those, if not all of them, have a graduate student or an undergraduate student as at least one of the authors. Most of them are driven by the graduate students themselves. So I wanted to highlight David Rakestraw, who's been featured in lots of things. He does physics with phones, which is talking about using the instrumentation that we all walk around with in our pockets now. And this is a huge boon for curricular development at the high school and college levels, like especially in lower division college classes. But for our students, people love it. People do freak out when he does that, like faculty too, who are really jaded, but he's got people climbing up on things, holding up their phones and stuff. It's fantastic. But for our students, they get research programs. Dave's like a phenomenal mentor, like just so good at connecting with them. And this is one of those programs that can deal with he's great at running a virtual team. So they're collaborating with people from all different ERIs. They're collaborating with scientists from Livermore, and they're able to work even while they're at home if they have other things that they need to do. Some of them have part-time jobs apart from this that they want to make sure they can keep. But they also are able to do this before they have other research experience sometimes, and it propels them into these other positions. So it's and it gives them good fundamental skills, right? Because this is something that a lot of our underserved students come in, maybe they were the top in their school, and that school had 16 people in it, right? We have folks from pretty small rural communities, and they were hungry for this stuff, but it wasn't available to them. So this is a great way to supplement a lot of their research and analytical skills, thinking about how to design curriculum for their peers using these instruments and understanding how they work. The other thing that I think is a fun part, but also an important part of all of this, and I guess since we're doing the science and policy part of things here. One of the things that I think is important in high energy density science curriculum development is including ethics and thinking about having a discussion of ethical frameworks and figuring out where to fit in all of this. And that's something that's often left out when we talk about high energy density science. So, come and correct from UC Merced, we want to make sure we have the justice tip in there. So we're thinking about how can we have our students engage around these things? And if you are trying to recruit a workforce for the Department of Energy, and you're doing that through the NNSA, and you're not talking about the impacts of those things on people from the communities that our students come from, that's a problem, right? So here, this idea is like, with all the attention toward the Oppenheimer movie, now we're thinking about, Dr. Atomic, which is an opera. It's a 2-act opera that was premiered at the San Francisco Lyric Opera, and talking about the struggles that Oppenheimer had. Here, there's also some podcasts that deal with it through speculative fiction, and being able to talk about these things involving the music department, involving our students who are not necessarily just physics students, but actually getting the entirety of our community, and readings like Nuclear Nuevo Mexico and other stories about the people who were displaced and disrupted by these tests, not only internationally, but also in the communities within the US where people were doing the testing. So this allows us to build curriculum that's unique also, right? It's not just being able to do what is available in high energy density science communities elsewhere, but thinking about how do we build something that is uniquely tied to UC Merced and the concerns that our students have. Our newest things, I know I'm getting pretty low here, so the newest things that we've been able to leverage through the DOE are some of the programs that were mentioned in the last talk. So this through the Fusion Energy Sciences, we're part of this Renew program, which Eddie and some of our other CFEDS collaborators are also a part of. This is led by Lawrence Livermore National Laboratory, but it's with the entirety of the LaserNet US facility list. And the idea is to have summer internship programs specifically targeted toward minority serving institutions students. And each one of our institutions decided a different way to leverage this opportunity. So like we are trying to really target these undergraduates that we're really hoping can, we want to make sure that our undergraduates get that early research education, so we're trying to use it to expand that and get them into facilities with, we don't have laser facilities at our 20-year-old research institution, right? I mean, we have some, but they're tabletops. they're not buildings where you like walk into them. So being able to do this is a big deal. I think, obviously, Morehouse is focused on undergraduate internships as well, but Florida A&M is thinking about graduate students, and they bring graduate students. So these Renew programs are 2 years. And so we had our first cohort last year, and they had a great time working at the Advanced Beam Laboratory at Colorado State University. They got to attend the LaserNet US conference, and they were fabricating nanowire arrays and irradiating them with petawatt lasers, right? This is huge, and it's a difference in levels, right? So we had a team that had somebody right after her freshman year, all the way up to somebody that was a rising senior, and they came from a variety of majors. And so one of them, as we move to our second cohort here, we're actually gonna have 2 cohorts where one of them is a more advanced cohort at Lawrence Livermore in the Jupiter Laser Facility, where we're trying to help them build on the experience they had at CSU and experience a different one. One of these students is locationally constrained this summer. And so for her, being able to do this at Livermore, where she can go back home on the weekends, is gonna be huge for her. And the only way that she could participate in research this summer. So to be able to take that into consideration and be able to talk to Livermore about that only comes from CFEDS. I wouldn't be able to do this year 2 of a program. It only comes because I'm able to talk to people that I've known since before CFEDS, really. So we're gonna have folks going back to the Advanced Beam Laboratory as well, and they're gonna be doing some of it similar nanostructured target fabrication and radiation, and then also a new project that they have in line, thinking about doing design, fabrication, and implementation of a laser system component, which is a totally different area. And then lastly, I'll briefly mention this FAIR proposal, which is, this is through, again, the Office of Science, so not through NNSA, but thinking about really bringing quantum chemistry into the high energy density science community more, thinking about what skills we have there, what talents in the student population, but also which techniques we have that aren't being leveraged for things about localized parts of high energy density electronic structure. And so we already have our first internship this summer. And the really neat thing about the FAIR proposal is that it stretches sort of what we've had as a really undergraduate focused internship aspect through CFEDS and also through the Renew program. Is here we're actually having graduate students. And this is intentional. And this again comes because our collaborator on this, Frank Graziani at Livermore, knows us and he knows our students. And that comes from the long-term true collaboration, not just the predatory version of this thing, and really getting to know what our students need. And so we're looking, and we have students on campus being supported this summer too through this. But I really do think that this sort of interplay of the different DOE programs has deeply expanded our research capacity. So I'm gonna just quickly show that we have this funding through the University of California Office of the President, this multi-research, multi-PI research grant, which is this massive collaboration. I mean, you can see here, there are a bunch of different people. This is a huge undertaking that's led by David Stribba, one of the PIs in CFEDS with us. And it's really thinking about how we can look at the transition from solid to plasma carefully. And we need a team this big to do that. But the reason why we could do this is not only because we've demonstrated that we can do meaningful work at UC Merced and through these collaborations, but because we actually know these people. Like the people leading the experimental effort, like Ronnie Shepard is one of the leads there. I don't think David knew Ronnie Shepard before we were working together in CFEDS, right? And now Ronnie teases David a lot, so I know that they get along, and they have this collaboration possible because of the long-term work towards students. And then we do a lot of stuff in my group. I'm going to stop here and just if anybody has any questions. My research capacity has been wildly changed by being a part of these DOE efforts, and that's not because I was trying to do that, right? I thought, what a great way to take money from the nuclear program and give it to underserved students. Like straight up, that's like how I think. I'm like, how can I take money from rich people and give it to black and brown kids from the Central Valley? That is a huge part of my motivation. I love science, I love physics, but the reality is that those students deserve to make their choices, have the ethical training and the scientific training to be able to figure out what do I want to do here, and this is one way to do that. And so I'm really grateful for the leadership. I mean, I think that's something that I said earlier in a slide that I went through very quickly. The mentorship through this program is also key for junior faculty, right? Being able to have mentorship from people in administrative roles already, right? And thinking about what it looks like on the path to tenure for junior faculty is also a key component for emerging research institutions. So thank you for your attention.
I think we have time for one very quick question. I'll ask one if no one else is standing up. So I think high energy density science is actually a great example for this kind of collaboration because it relies on the kind of facilities for experiments and computers that even our one institutions don't have.
Yes.
Right? These are user facilities that are large, that typically have submission-based user programs, right?
Mm-hmm.
So I'm wondering if there are some lessons learned in the very short time we have left to transfer this kind of collaborative model to other parts of physics, like astronomy, where you're applying to a telescope, or condensed matter, where you're going to a synchrotron or something like that, for other user facility-based.
Yeah, I mean, I think these DOE programs are really set up well for that. The Renew and the FAIR proposal, where the demand is to collaborate between, like for the FAIR proposal, you have to have a DOE facility pairing with an MSI, or they claim an MSI R2 with an R1. But I don't think they actually funded any of those in the first time. I think they wanted to really fund the National Lab MSI collaborations. But that's a great place to go to do this. For us, one thing that's been really key, and I think Livermore is very good at understanding this, the reality of the lack of staff support and infrastructure at smaller institutions is very, very difficult for navigating these larger collaborations. And so the fact that Livermore thinks about how to facilitate that stuff and is responsive most of the time, like at finding how we can use their administrative support. So if you can do that, or I don't know how much you can fund it through there, but a lot of the time when you talk to the program officers and ask them like, how much can I support this sort of a thing there? I think they know that. The DOE seems to get that the lack of infrastructure is really limiting. So, but yeah, I would say any place that has a user facility model, these are like exactly ripe for harvest, right? I mean, that's exactly it. But you can think about that just anytime there's a mismatch, or maybe just say like a collection of talents, or just facilities or resources in the different institutions, thinking about how you pair that up well. Because I mean, I think we do that now, right? Like, we have a 1-1. So yeah, we should be publishing more. So when we go to report what CFEDS has done and we report those publications, hopefully that's bolstering the whole group, right? Because we don't have like 3 or 4 classes that we're teaching every single semester. But at the same time, if I need to talk, I'm going to talk to Ron Williams about how to teach something in a physics course if I don't know how to do that. I'm not going to David Striven, though David's a great teacher. He's not in the trenches, and he's not a master teacher, right? So figuring out where those resources can be balanced, you can think of it the same way as a user facility, I think, in some ways, like that. But you can highlight that in your proposal, right? Highlight the strengths of each institution and how they complement one another. Yeah, thanks.
Thank you, Laura. All right, our last speaker of the session is Professor Alexandra Miller from Sonoma State University. Her presentation is Collaborations Between Emerging Research and R1 Institutions, moving on from the national labs, a success story, hopefully ending on a high note.
Yeah. All right. So, can you hear me? Is this okay? Okay. So I'm so happy to be here today. I feel very fortunate to have been invited to give this talk. I certainly don't know that I am an expert in forming these collaborations, but I'm going to tell you about a couple things that I've been a part of, and a particular program that I am the PI for. And so I'll tell you about this one thing that we did, and hopefully you can learn something from it. And is this not working? Maybe. No, it's not working. Okay, great.
This pointer is better as well.
Oh, great. Awesome. All right, so for those of you who have been here since the beginning of the session and heard Anna's excellent talk, you already know all of this terminology, but I know some people recently walked in. So just to make sure we're on the same page, when I'm talking about, I'll use all of these different terms here in my talk. So R1s, of course, are doctoral institutions with very high research activity. I'll often in this talk, I'll talk about R1s, but I'll also talk about research institutions more generally. So trying to include things like national labs. So when I say research institution, I'm sort of talking about R1s, maybe R2s, and research national labs. A PUI is a primarily undergraduate institution. So these are institutions that maybe they have 1 or 2 PhD programs, but pretty much they're just granting bachelor's and they have some master's programs, but only a handful of PhD programs. Minority serving institution, actually my understanding of this was a little wrong, and I learned a lot from Anna's talk, which to be a minority serving institution generally means you have I always think of it as you have a certain percentage of a particular minority group at your institution. Turns out there's other things that you need to qualify for that, but that's sort of one of the main aspects. Sonoma State, where I come from, is a Hispanic serving institution, and so I'll specifically be talking about HSIs a lot. And then, of course, the session is about emerging research institutions, so ERIs are emerging research institutions, which I had never heard of before I met Anna, and I was invited to give this talk. So again, if you were here at the beginning, you already heard this. An emerging research institution was a designation that, while sort of the idea has existed for a while, it was only defined in August 2022. So this is a really new designation that's going to be very important, and it might affect you when you're applying to grants in the future if that's your role. And to be an emerging research institution really just has to do with how much funding you are currently receiving. And the idea for this, as again, this was really the point of Anna's talk, is this is to increase equity in federal science funding. Because it turns out to get, so there's a lot of grants currently, and the program that I'll mostly be talking about today, I was able to get because Sonoma State is a minority serving institution. But it turns out a lot of institutions that you might think should be classified as minority serving institutions don't actually qualify. And so this new designation is there to sort of really bring in those institutions that really should have been included from the beginning anyway. Okay, so setting the stage for me, for where I'm coming from. So I'm at Sonoma State, which is one of the California state universities. So I imagine if you're not from California, you maybe are familiar with the UCs, like UC Berkeley, but you might not be familiar with the CSU system. In California, we really have 3 public university systems. We have the UCs, again, which these are research institutions, they're PhD granting. They're the ones that you're familiar with. They're the famous ones. California state universities, these are primarily undergraduate institutions. So they're all PUIs. So we do have some PhD programs, but it's mostly bachelor's, master's programs. There are 23 campuses. We're one of the most, if not the most diverse public university system in the United States. From what I could tell, all but one, which I think it's just Maritime, which is a really small institution, all of them are minority-serving institutions. So we are fortunate that most of our institutions actually have that minority-serving designation already. And then all of us would be classified as emerging research institutions. So Sonoma State, where I'm specifically from, of course, this is located in Sonoma County, which is in Northern California. It's about a 2-hour drive from here. So if you drove towards the coast, you'd get there. We're one of the smaller CSUs. So currently we're about 6,000 students. So like sort of Aurora mentioned, like we'd like to be closer to maybe 9,000, but in this post-pandemic world where people aren't going to college as much, we're closer to 6,000. We're 90% undergraduate. So again, we do have some master's programs. I don't think we have any PhD programs. Maybe that I should probably know. But 90% undergraduate students. We are about 40% Hispanic, 48% first generation. And one thing I want to mention about our student population that was incredible to me, I'm still surprised all of the time, is that many of our students work 20 or more hours per week. It is not uncommon for me to talk to a student and have them say, oh yeah, I'm working 30 hours this week, on top of being a full-time student. And the reason I really want to mention this is in thinking about getting these federal dollars to students at institutions like mine, like it's so important because they won't have the time to participate in research activities unless if you can pay them to do it. Like it just, for many of our students, it's not going to happen. I mean, maybe they could do it and then they're going to fail all of their classes, right? So we need this funding if we want to support these students and bring them into, for me, the field of high energy physics is what I'm concerned about. We're at April Meeting, right? We need to have the money to give to them, to support them in order to do that. So what is it like to be a faculty member at Sonoma State University? So maybe you're someone from an R1 and you've never collaborated. You don't really know what it's like to collaborate with a PUI faculty member. Our jobs look very different than R1 research institution faculty members, right? So I teach 12 credit hours, so this is 3 to 4 courses per semester, unless if I have release time. So fortunately, I do have one of these DOE grants, so I'm getting 3 units of release time. So I'm only teaching 3 classes this semester, so now I have all sorts of time. We have also very high service expectations. I mean, this is probably true, feels true everywhere, but I spend a lot of time on committees. And one thing that's also really different about being a faculty at a PUI is I do research, and I have research requirements. I'm an assistant professor, right, so I'm tenure track, but I haven't gotten that tenure yet. Maybe later next month I might find out. But our tenure requirements for research are different than an R1 institution. Like, we're required to complete research, but there's a much greater emphasis on involving students and mentoring students in our research. Like when I got the job at Sonoma State, they didn't just want to know like, oh, can I continue doing research? They wanted to know, can you involve our undergraduates? And let me tell you, I am a theoretical quantum gravity person, and so it was a little bit of a hard sell. But I do work with my students. And so when you're thinking about if you're coming from an R1 and you want to collaborate with someone at a PUI, this is something that's going to be really important to us, is involving students. So the two programs that I'll talk about today, you'll see, are really very student-centric, right? They are also supporting me in my ability to do my own research, but in a very student-centric way. So the first program I want to talk about, this is not my program, but this is a program that I was heavily involved in. I was on the steering committee for it for 4 years. And I really learned a lot. And actually, so Wing, who I'll introduce more later, because the second program I'll talk about was really his brainchild. We met through this program. And a lot of the people I met who then ended up being involved in the program that I was a part of starting, I met through this CalBridge program. So if you're someone, I know there have been questions about like, oh, if you're at an emerging research institution, how do you get this thing going? I think if there are any programs like this that you can sort of get involved with, that for me was really the gateway in order to developing my own program. I'll also say both the programs, so both this one and the next program I'll talk about, really started at the CSU. So they did not start with some R1 professor being like, oh, I want to get this grant, like, let me pull you on. They started at the level of the CSU, and then we reached out to the people at the national labs and the R1s. And people wanted to work with us. They were aware of these grants that need to involve minority-serving institutions. So they were very happy. They were very happy to join our team. Okay, so the first program, the CalBridge program, which again I've been heavily involved in, but I was not the creator of. It was created while I was still a graduate student, so. This aims to create opportunities for historically underrepresented groups to increase their opportunities, which I have twice in that sentence, sorry, really their participation in PhD programs, right? So this is 100% a student-centric program. This is not really about doing research at all. It's about helping these students. I mean, ultimately, at the end of the day, they're going to contribute to research. But this is really a totally 100% student-centric program. The bridge part of it is that it's a bridge between the CSU, which again are these primarily undergraduate institutions, and UCs. So this is getting our undergraduates from the CSU and helping them to get into PhD programs, primarily at UCs, but actually we have other partnering institutions, like Caltech is one of our partners. This was originally an NSF-funded program, but currently it's being funded by the state of California. So I learned a lot from this program, and actually when we developed our own program, we sort of stole a lot from their playbook because it worked out really well. So their program is a 2-year program that supports underrepresented students over the last 2 years of their undergrad. And it's really important that they have those 2 years because, as I mentioned, so many students at Sonoma State, and then definitely many students in CalBridge, are first generation. And so what that means is even though they're highly capable students, many of them have not had mentoring like from their families about how academia works and what it means to go to grad school. And the fact that if you go to grad school, if you go to a PhD program in physics, it's paid for. You aren't going to go into debt, right? They don't necessarily know these things. And so this is designed to be this full 2-year program where the students have actually 2 mentors. They're assigned a mentor locally at their home institution, as well as one at a UC. And so they have this really close relationship, hopefully, with their local CSU mentor who knows what their classes are like, knows what their day-to-day is like. But then they also have this UC mentor who's really going to be able to help advise them in that transition. It comes with money, actually, and I think this slide is out of date. I think now they can get up to $15,000 per year. Because again, if we want to help these students, to help support, again, these highly capable students, they need that money because otherwise they're working 30 hours a week. When I was on the steering committee and reading applications for this program, all the time I saw students working, I mean, to me, that's like absurd. Like, I don't know how you're a full-time student and you work 30 hours a week. But our students do it because they work very hard. But that means the only way they can start to get involved in research is if we can give them funding. This program comes with professional development workshops. And then a big part of CalBridge now, they sort of have a separate thing called CalBridge Summer, which you don't have to actually be a CalBridge scholar to be a part of it, which is it's a summer REU program. But it's really one application that then goes out to many, many REUs. So then for students who generally have to like apply to each REU individually, this is really nice. So for any students in the audience, which I think mostly are students who are right here, so maybe you guys are all familiar with this program, hopefully. But maybe someone will watch the video and they've never heard of CalBridge. If you're a student and you're interested, it's now open to all of these fields. CalBridge started in just astronomy and then it expanded to physics, but now it's in all of these other STEM fields. If you wanted to apply this year, you need to be on track to graduate in 2025, 2026, because again, this is really strictly a 2-year program. Again, it's aimed primarily towards, to increase the diversity in PhD programs. So far, there have been 10 cohorts of 300 scholars total. 90% ended up being enrolled in graduate school. 62% of these were first generation. Again, this is why the mentoring is so very important. 59% are underrepresented minorities. 39% identify as women. 27% LGBTQ+, and 17% are underrepresented minority women. And so these are very diverse groups of students. And so if you're a student who's interested, the deadline is real soon. So I had to throw that out there. Okay, so through this CalBridge program, I met a lot of people, right? So it's a bridge. So all of the CSU campuses are involved. So I met many people at CSUs. But then also we have the UCs, so I made many connections. So David Struba, who was mentioned a lot in the previous talk, I met through the CalBridge program, right? So for me, being involved in this program really opened the doors to starting to build these collaborations, which then helped lead to the next program, which is the Growth MSI program. So this was funded by the Renew program, so we just heard about the Renew program in the previous talk, which again is reaching a new energy sciences workforce. And this is really an initiative put out by the DOE to bring in institutions which were historically underrepresented in the Office of Science research portfolio. So Sonoma State University has never had any funding from the Department of Energy before. I guess there's a little bit of a lie there because I guess one computer science professor sort of had like some contract funding, but we've never gotten a grant from the Department of Energy before. So this was the very first time that my institution ever got any money from the Department of Energy. This program has 2 PIs, so myself, but then Wing, who everyone should look at Wing over there, because really this program was his brainchild, right? So credit where credit is due. He was the one who first had the idea for this and reached out to me. And I'll say again, thinking about how do these programs actually happen? So Wing contacted me about this. So again, he's at Stanislaus, which is another CSU. So it came out of the CSU. But actually, I was around the same time contacted by some folks from Lawrence Berkeley National Lab who knew about this Renew program, and they were trying to get something going. And so then we ended up just sort of combining forces. So again, if you're at an emerging research institution and you want to get something going, reach out to those folks at R1s, because they're probably going to be very happy, or at national labs in this case, right? They're going to be happy to work with you. Okay, maybe not all, but who cares about those guys? Then you don't want to work with them anyway. So this program really has 3 aspects to it. So the first part, again, it's very student-focused. So the first and most important part is the high energy physics traineeship. And now I have to call out this whole row right here, which these are all students in our first cohort. So wave everyone. Hello, thank you for coming. So the biggest part of this is this traineeship for students who are interested in careers in high energy physics. So these could be people who want to go on to graduate school, or maybe not. Maybe they will just want to get their bachelor's and then get a job in high energy physics in some way. And so, you know, this program is not, again, it's not like for my specific field of research. It's not a program that I made so that I could spend lots of time thinking about quantum gravity. Instead, it's really focused on the students, and we wanted it to be broad because our students are going to have different interests, right? If you asked all of these students right here, like, what specific area of high energy physics do you want to work in, you're going to get 6 different answers. So we wanted it to be broad so that the students can really do what they're most interested in, even though they should all want to work in theoretical quantum gravity, of course, right? So the second part is building up high energy physics research foundation at Sonoma State, where I am, and at Stanislaus, where Wing is at. And then the third tier is a development of a high energy physics consortium in primarily Northern California, with the hopes that this is something that is developed in these first years of this program, but that will continue beyond the program. So again, I think if you're at any of the institutions, which UC Merced is one of our partnering institutions, right, you could join our consortium, and we just, you know, the more the merrier, right? So who's in our particular consortium? So it's mostly in Northern California, although you'll see this little outlier, UC Santa Barbara, which is partly both Wing and I went to grad school at Santa Barbara, so we tagged them on. So the schools in yellow are all minority-serving institutions, and these are really the schools where we're getting our students from. So if you are a student at Sonoma State, San Francisco State, East Bay, Stanislaus, Merced, or Fresno, and you're interested in high energy physics, then you can apply to our traineeship. Our program is actually a 1.5-year long program, so I sort of think of it like an REU on steroids or something, right? Like, so a big part of it is a summer research opportunity, but our students are in the traineeship for a whole 1.5 years. Because let's be honest, I mean, summer REUs are great, but in 10 weeks, what can you really do? And so our program gives the students more time in order to really learn and contribute to some science. So ultimately, our students are going to be assigned research mentors. This should happen in the next couple weeks. So Lawrence Berkeley, UC Berkeley, Lawrence Livermore, SLAC, or UC Santa Barbara. So these are our sort of research institutions that are on our partnership. So our students are going to be assigned, I'll talk more about the traineeship in a minute, but they're going to be assigned research mentors at these partnering institutions in the next couple weeks, and then they'll have the rest of the semester to start, you know, oh, you need to know Python in order to work in my research team. So now you can spend the last part of your semester getting paid in order to start to learn Python, so that when you go to your summer research REU, you already know that. You've already read some papers, right? So you can really start doing research right away. So in preparing this talk, I wanted to really think about, like, what are things that I didn't know about that if I were to want to do something like this in the future, I would need to know about? So one of those things that I didn't know about, and it's a little complicated aspect of our grant, is sort of the multi-institutional structure of it. And so I just thought I would briefly mention, like, if you're applying to a DOE multi-institutional grant, right, because that's what this whole session is about, is forming these multi-institutional collaborations. How does that work? And we really used both of these structures in ours, which is what makes it extra complicated. So you could create a grant which is collaborative. So in our grant, both Stanislaus and Sonoma State are sort of using this collaborative grant structure where we're each receiving our own pockets of funding. So Sonoma State got some funding, Stanislaus State got some funding. So my students, for instance, are all funded by specifically my funding at Sonoma State. But you might be wondering, I just listed all these institutions that are not Sonoma State or Stanislaus State. So we have this collaborative grant structure, but then below Stanislaus State were many sub-awardees. And so all of the other institutions that are a part of this grant technically have sub-awards, which means that their funding is sort of funneled through Stanislaus. And a big part of why you would want to include this sub-award structure if you are developing one of these grants is because it really provided a lot of flexibility. So you'll see in a minute, I'll talk about our first cohort that just entered the program this semester. We didn't have a student from every single institution, right? We didn't know beforehand how many students we were going to have at each institution. And so this allowed us to have a lot of flexibility in that, because we're like, oh, we didn't get any students from Fresno this year. No big deal. They don't have any money anyway. So like, you know, so that really was important. So in thinking about developing a program like this, knowing about these structures, you know, that's possible. And I'm sure NSF, you know, different agencies probably have different structures, but maybe they probably all have something like this, hopefully. So again, we have our first cohort. Many of our students are right here. So just thinking about, and what's my time? I still have 5 minutes. Okay, we're okay. So our students, just letting you know what this traineeship looks like. So last semester in the fall was when we were sort of starting to advertise this traineeship. And we really wanted students to apply as juniors. And when I say junior, I mean most of our students are not on a standard 4-year track. But I mean, if you were on a standard 4-year track, you'd be a junior. And so we were focused on sort of attracting students who, at that time, they'd be probably in modern physics and math methods. And most of our institutions, these were sort of classes you might be taking in fall of your quote-unquote junior year. So this is when our students applied. And then currently, we're in spring 2024, and we're offering a particle physics class, which Wing is the primary instructor for. I'm sort of a secondary instructor just to help out a little bit when I can. Online, right, which in a way this is one of the nice things that came out of the pandemic, right, is that we're so much more connected via Zoom primarily. And so we have this online course because most of our institutions can't offer a particle physics class. But because we have this whole consortium, and actually this particle physics class is available to any CSU student, not just students in our program. So we have, I think about half the students are trainees, but then half are just CSU students who wanted to take a class in particle physics. So that's what our students are doing right now. They're also participating, hopefully, in some amount of professional development. So I know at Sonoma, I meet with my students every week, and I've had them look through like the APS Careers Handbook, right, just to start to think about what's possible. We have a weekly seminar, which are talks given by the researchers who ultimately will be research mentors for our program. And then pretty soon, they're going to start doing their sort of independent study for their research project. So pretty soon these will be assigned, and they'll start them. This will build up to this summer where they'll be doing full-time research at their participating research institution. And then our program continues beyond that. So again, most RIUs are just that 10 weeks, then it's done. We will continue to fund the students, to pay them, beyond the summer, right? So, and also this summer, they're getting a stipend for living and a housing stipend. In the fall, they will continue to have funding available to continue research remotely. So they could be doing some data analysis. I mean, hopefully, eventually, they're helping to write a paper. That would be like the dream, right? But in whatever way they can continue doing this research remotely, they will continue to do that. Their mentors then will be helping them also think about if they want to apply to graduate school, which, you know, some of our students do, but that's certainly not a requirement of our program. Next winter, we'll have a symposium where they'll be presenting their research. And then finally in the spring, which would be their last semester in the program, if they're still working on that research project, great. Many of our institutions require sort of senior capstone projects, and so for most of our students, we expect they'll continue doing this research as a part of their senior capstone. Again, their mentors that are assigned to them will be, helping them, think about professional development. So if they're planning on applying to jobs right after, helping them put together a resume, right? Or helping them to prepare for graduate school, and then also presenting at April meeting next year. So, so hopefully if you're all at April meeting next year, our students will be there, all of these students right here, giving talks about the excellent work that they did. This was the flyer. We don't really need to dwell on this. So again, we have our first cohort right now. So we ended up with 7 trainees totals from 4 different minority-serving institutions. They're currently in this particle physics class, and they attend a weekly seminar. So these are some of the flyers for some of the seminars. So these are the wonderful folks at research institutions who are, actually for this, they're really volunteering their time to give these seminars to our students so that they can learn about the different fields of high energy physics. Because, right, when you're a junior, you don't necessarily know, like, this is specifically the thing that I want to do and research on for the rest of my life, right? So here they're learning about all of the different things that are going on, and then ultimately we'll be matching them with these folks who will start to mentor them immediately and then through the summer and beyond. The next here, I have 19 seconds left. So, so the next part is to develop research at Sonoma State University in Stanislaus. Since I'm from Sonoma State, I'm going to talk about mine. It's really supported me to work with my students to write a primer in conformal field theory, which is a field of physics that usually you don't learn about till third year of grad school. And all the resources on conformal field theory are written assuming you've had a year of quantum field theory. So if you have any students who are interested in learning about conformal field theory as an undergraduate, look up our primer, because we actually finished this as a part of this grant, and now I'm working with another Sonoma State student on a follow-up. And it's really because of this grant that I was able to develop this resource. So again, this is, I'm sort of doing research here, but it's very student-focused research. We're putting out publications, but very pedagogical, student-focused. And then again, we've successfully sort of developed this consortium, which we hope will foster future collaborations between all participants. So some main takeaways, right, from my talk and hopefully from all of the talks is that if we want to diversify physics, we need to find the students where they are, right? Where are, diverse groups of students? Well, the CSUs and many other institutions, right? Collaborations between emerging research institutions or PUIs, that's going to support the growth of these students. And it's fortunate that it looks like federal and state programs are really increasing their support of these endeavors. So we want to take advantage of that. Thank you.
All right, we have time for questions.
Yes.
So when you're talking about the year-and-a-half program, they're starting, they know coming in January that they've been selected for the program, and they sort of start.
Yeah.
Okay, I have an undergrad program that I do sort of similarly, where they're doing prep and then they go.
Yeah.
They go to Australia. It's like a
Oh,
whole
that's
crazy
cool.
thing. There's an NSF program for that, if anyone wants to talk about that, sending folks for international research experiences. But then when they come back, it's optional for them whether they keep working with us, but most of them choose to. But they can't keep doing that research. So, but these students are actually engaged in the research still with the mentor.
That's the hope. I mean, of course, it depends on what the particular research project looks like, and whether the student, we aren't going to force them. They haven't signed. If they're like, I did not care for that research, I didn't care for that person I was working with, they don't have to.
I see.
But ideally, the research will continue. And again, partly because we are, most of the institutions are Northern California, it's still possible for them to go back and, on the weekends every once in a while and work in person. So,
That's awesome.
yeah, we wanted it to be flexible. And that part of it is very flexible. And, it's our first cohort, so I don't know what's going to end up happening. comment.
comment
Good,
on that.
thanks.
The mentors do actually appreciate that they could work with the students afterward, because they're not constrained to this 10 weeks or nothing thing anymore. So it's actually we chose the mentors that wants to work with the student even after their summer research, and therefore they can wrap things up, do analysis and maybe write a paper about it.
Yeah. I mean, again, that's always the dream, and a big part of it is right because I mean, we have students who have done a summer RIU and continued working with their advisor, but where's the funding for that coming from? So our program already has that funding for them to keep doing that work. Yeah.
Anna?
Thank you for your talk. As part of the professional development that you offer to students, do you talk about or provide support in applying for things like the National Science Foundation Graduate Research Fellowship, where CSU is just unbelievably underrepresented in those types of like nationally competitive STEM graduate fellowships?
Yeah, 100%. So when I mentioned it sort of in that fall, their mentors will be helping them apply to grad school. We'll definitely be also helping them apply to things like that. So 100%, yeah.
I had a question about the mentors and
Yeah.
how you go about recruiting them, how people can come into this program from the mentorship side.
Yeah, so part of it is when we developed it, so we had we do have officially co-Is at all of our institutions. So those are sort of our default, especially because so each student has a mentor that's at their home institution. And so that, I think, by default is the co-I on the grant. But then at the national labs, right, we have potentially lots of research mentors, and partly the co-I so we have one co-I at each institution. In a way, we sort of turn to them to say, hey, can you email your colleagues and help find us research mentors? So that's a part. Or, we talked to a lot of people when we were developing it, so.
Yeah, I found myself thinking about how to expand the program from the lab side.
Yeah.
Yeah. Where they do have resources for like their own summer internship programs and things, and often offices that deal with that kind of thing and finding placements for like summer students, and if they can be mobilized to also help find these kind of mentors for year-long commitments. But
Yeah, so far, I mean, we have plenty of mentors who are sort of signed on. So like I said, all the folks who gave those seminars are definitely people who are willing to take on students.
Okay, any final questions? Anna?
Yeah.
So I have one more question. So when you look at the networks of research collaborations among, say, R1s, right, they span not only the nation but the world. However, when you look at the research collaborations, that web for regionally focused institutions, they're usually very state limited. And so I don't understand why that has to be though, right?
Yeah.
Because if we're doing things virtually, so I just was wondering if you could say a bit about when you were conceiving this, why limit yourself to your lab and R1 collaborators that are at in California? Like, why not Fermilab?
Yeah, so that's a great question. So 2 answers. So for my personal research that doesn't necessarily involve students, I am collaborating internationally. Like I have a collaborator who's currently in Paris, right, who I definitely do research with, which does not have any funding tied to it currently. With this particular grant, what we focused regionally, a big part of it is because of the things you guys talked about, which is it was very student focused. A lot of our students are location bound, and so I think a big plus to that is that our students with families can potentially do one of these RUs and not have to go too far. That being said, I could envision future growth of this growth program, which does include other, that goes further.
A little
Yeah.
bonus that I didn't realize when we started this program is that their families come visit them in their labs, which is a really big plus. So if you were at, at Fermilab, they would have to fly out from California, and then, I know students who have brought their family to our lab and just showed them around, and that was one of the really proud moments for the students also.
Yeah. Yeah, I'm on our Sonoma State Scholarship Committee, and was recently reviewing scholarships from across the university. It was incredible to me how many of the students, so, I mean, we're talking about students that not only maybe have their own families, they already have children, but also so many students mentioned like, oh, I'm the eldest daughter in my family, and that means I have a lot of familial obligations. And so I don't know, I mean, it came up in like, there was a very high number of students who specifically mentioned this obligation to their family. Yeah.
We have about 10% undocumented students at UC Merced, and for our students, if we're paying through a stipend, which we often can do, especially for AB 540 students who are sort of recognized by the state of California, for them, they or often their family members are able to actually be funded for research and like think about grad schools and things like this. But for us, it's a really, I mean, 10% of our students is a huge number of students. And even if they are not themselves undocumented, most of them have undocumented family members. And if something went wrong out of state, so this is something that, like I mentioned the Australia thing, we have a bunch of things that are out of state or international, and it's actually very hard to recruit in a way that, you know, for those of us that are like, I'll go anywhere for like whatever I'm doing, right? Like that's not always the case for everybody. And so for them, the locational constraint cannot just be social, but also like actual legal constraint for a lot of them. So I know this is part of why we, we think carefully about this now when we're designing these things.
That's one of the reasons I included a couple of UCs in the grant also, because the DACA students would not be able to get into the national labs.
Yeah, smart.
All right, thank you very much. Let's thank all three speakers one last time.